All right, now we're talking about proofs about limits. So this theorem states that the limit of a sequence when it exists must be unique. Recall that a sequence, let's say xn, converges to a limit, call it x, if for every epsilon greater than 0, there exists a big N in the natural numbers such that whenever small n is greater than big N, it follows that xn minus n, the absolute, or the distance between the limit and the elements of the sequence, the terms of the sequence, is less than epsilon x, sorry. All right, so that's the definition of a limit, and this will be handy when we are proving the uniqueness of limits. So the proof goes like this. Assume that xn converges to a and xn converges to b such that a is not equal to b. So we are going to assume that a sequence converges to two limits that are not equal. We argue that a equals b must be true by, we're going to form a contradiction when we assume that a is not equal to b. All right. Let epsilon greater than 0 be arbitrary. Fix or consider a particular epsilon be 1 over 3 over b minus a. So this is basically just a 1/3 of the distance between a and b, the limits. And why we do this is, let me show you a visualization of what's going on. So let's say we have a and b, these are the limits, and we're going to let epsilon be 1/3 of the distance between a and b. So we can divide ab into 3 segments, and this is going to be the epsilon neighborhood of a, and this is going to be the epsilon neighborhood of b. All right. So since the sequence xn converges to a, I'll just use notation. There exists n1 and n such that n greater than or equal to n1 implies that xn minus a is less than epsilon, right? And there also exists n2 such that n greater than or equal to n2 implies that the distance between the terms after the n2 and b is less than epsilon. All right, we're going to let n be the maximum of n1 and n2. So since we're letting n to be the maximum of n1 and n2, it follows that n greater than or equal to n implies both of these to be true. All right. So we know that 3 epsilon is just the distance between a and b. And before that, epsilon was 1/3 and absolute value of b minus a. Just multiply 3, and then we get 3 epsilon to be the distance between b and a. Well, we can use a clever trick here. This same thing as saying a minus b, and then a minus xn plus xn. So we're going to subtract xn and add xn, which we can do that, which is going to be the same expression. And by using the triangle inequality, this is going to be less than or equal to a minus xn, absolute value, plus absolute value of xn minus b. And we know that for n greater than or equal to big N, which was the maximum of n1 and n2, it follows that this a minus xn plus xn minus b is going to be less than epsilon plus epsilon, which is 2 epsilon, right? Because after the big N term, we know that the difference between the term and the limit is less than epsilon. So we use the fact above to show that this triangle inequality is less than 2 epsilon. Wait a second. That means that 3 epsilon is less than 2 epsilon. A contradiction, since epsilon was greater than 0. We can't have 3 epsilon less than 2 epsilon when epsilon is greater than 0. That is just absurd. Hence, A equals B must be true, since we got this contradiction by assuming that the two limits are different. Thus, a limit of a sequence when it exists must be unique. And that's the end of the proof.